Hi, this is TSA 2016 Section 1, Question 48. So the planet Melpomene has 3 moons, and each of them are moving at a constant speed in the same direction in circular orbits, and we're told the orbital periods of each of these 3 moons. And we're asked how often are Melpomene and its 3 moons in line with each other in this order here. Okay, so for these planets to be in line with each other, then they all must be the same fraction of their way through their current orbit. Right, so imagine that the planets started here, and now in this position they're all in line with each other again. Then however many full orbits Othello has done, it's this fraction of its way through its current orbit, and similarly for Hamlet, however many full orbits is done, it's now this fraction of its way through its current orbit, and the same for Romeo's. Okay, so now that we know this, I think the easiest thing to do is probably just to use the answers that they give us. So let's think about what would happen after 36 days. Well, Othello's orbital period is 20 days, so it will be 16 days into its current orbit. And Hamlet and Romeo both have orbital periods that are longer than 36 days, so they'll be 36 days into their current period. And if we look at that as a fraction of their current orbital period, we can definitely see that these fractions are not the same. So 36 over 45 is not going to be the same as 36 over 120. So the planets aren't going to be in line after 36 days, so we can rule. Okay, so what about after 72 days? Well, after 72 days, Othello, with its 20-day orbital period, will have done 3 full orbits and be 12 days into its current orbit. Hamlet, which has a 45-day orbital period, will have done 1 full orbit and be 27 days into his current orbit, and Romeo is 72 days. So if you write that as fractions of their current orbital period, and we can simplify these fractions down, so 12 and 20 are both divisible by 4, so dividing top and bottom by 4 gives us 3/5. 27 and 45 are both divisible by 9, so again we get 3/5. And 72 over 120, they're both divisible by 12, and dividing through would give us 6 over 10, which we can see again is equal to 3/5. So after 72 days, all 3 of these planets are 3/5 of their way through their current orbit, therefore they would be in line with each other, and so B is our answer.